Hello and welcome to my channel. I am Mensa Augustine. In this lesson, we are going to look at definite integral as the limit of a sum. Now, thanks to Nityananda Berry from Dugapur, West Bengal, India, for giving me an in-depth knowledge about this topic. Now, let's see how we do this in a very simple way. Kindly follow me on my Facebook page and also subscribe to my YouTube channel for us to grow the mathematics community. And leave your comments and like the video also as well. So let's see how we do this. Now, we can just multiply through by n divided by n. So we multiply this one by n divided by n. So I'll let this n go through. Wow. So I'm going to get the limit as n goes to infinity, 1 divided by n. Then I'm going to have n on n plus m plus 1 on n plus 2m plus 1 on n plus 3m plus plus n on n plus nm in a very simple way. I've said Nityananda Berry from Dugapur, India, West Bengal, he gave me a nice tutorials on this. So I'm good at it. Now let's see. What do we do? Wow. We have n here and we have n here. Now, we're going to do this. We're going to divide both the numerator and the denominator by n. So we're going to have the limit as n goes to infinity, 1 divided by n into n divided by n is 1 divided by n divided by n is 1. Then you have plus m divided by n. But this can be written as m times 1 on n plus the same thing, 1 divided by 1 plus m times 2 divided by n plus 1 on 1 plus m times 3 divided by n plus up to plus 1 on 1 plus m divided by, m times n divided by n in a very simple way. Look at how I did here. Here it is n divided by n divided by n plus 2m divided by n. So you have 1 on 1 plus, this m is a constant, so I bring m here, then 2 on n. That's what we've done here in a very simple way. Now, we are now going to add or sum these partial sums together. So let's see. We're going to write this one as the limit as n goes to infinity, 1 on n times the summation from r equal to 1 up to infinity of, this is what we do. We have 1 here, we have 1 here, plus m times rh. Look at this rh in a very simple way. So here we are saying that 1 on n equals h, or 1 equals nh. That is very simple as that. So this is the same as the limit as h goes to 0. Then h times, h times summation r equal to 1 up to n. Then we take 1 divided by 1 plus, so we go here. Wow. I think there's a mistake here. Yes. Here we have m times r on n. Yes, it's m times r on n because we have r to be 1 1, 2, 3 going. That is r equal to 1. So r on n in a very simple way. So here, the r on n will now change to m times rh in a very simple way. I hope this one makes a lot of sense in a very simple way. So why are we taking h goes to 0? Because from here, as n approaches infinity, you see that h will be 0. Because as this n becomes extremely large, then 1 divided by a very large number will give us 0. Wow. So from here, we're going to replace this by the x and replace this one by x. So this changes to the integral 0 up to 1. Zero up to 1, then we have 1 divided by 1 plus mx, and h becomes dx. So rh becomes x and h becomes dx. So we have this integral to integrate. Wow, no problem. So let's integrate. Now this integral can be written as the integral from 0 to 1, m on 1 plus mx times 1 on m dx. If this m cancels this m, we come back here. So we factorize 1 on m out to get 1 on m times the integral from 0 to 1 on, m on 1 plus mx dx. Now, we use the substitution method. So if we let u to be equal to 1 plus mx, you're going to get du equals m dx, and du on m equals dx. That's very cool with it, right? So we are going to get this one as 1 on m times the integral. Okay, let me put in, if u equals, if x is 0, so if x is 0, we're going to have u equals 1. So we are going to have 1 here. But if u equals 1, x equals 1, we're going to have 1 plus m. We're going to have 1 plus m at the top here. Look at this. If we put x equal to 0, m times 0 will be 0, so we'll be left with 1. But if we put x equals 1 times m is m, so we're going to get to be 1 plus m in a very simple way. So let us put here. So we have 1 on m divided by u du on m. And here, this m will cancel this m. So we're going to have this to be equal to 1 on m times the integral 1 to 1 plus m, 1 on u du. And if we integrate this, we get ln of u. So we put the ln of u. So let's go. So we're going to write this one as 1 on m, 1 to 1 plus m, then ln of u for this. But what is u? U is 1 plus mx. So let's put it here, 1 plus mx. So what do we do? If we put in 1, we have 1 on m, ln of 1 plus m. Then minus, if we put in 1 plus m for x. Wow. It has a very big mistake because we've made the u substitution. So we're just going to take ln of 1 plus ln of u, right? That's all, and do our substitution because the limit has been changed to u. So we have 1 on m ln of 1 plus m minus ln of 1. And this is 1 on m, ln of 1 plus m, because ln of 1 is 0. You will not get that in a very simple way. So this is a very nice solution. Thank you for watching. Please like, subscribe, and leave your comments for us to build the mathematics community.